Edit this out later. Hey everybody, today we are debating evolution versus intelligent design, and we are starting right now with Eric's, aka Planet Peterson's opening statement. Thanks for being with us, Eric. The floor is all yours.
You're very welcome. Thanks, Modern Day Debate, and thanks, Sal, and thanks to myself for being here too, I guess. So let's just imagine, we'll set this up. Two people, they disagree on the cause of something. One person says it was X, and the other person says it was Y. So we want to ask ourselves, how's a neutral observer, and that's you watching this, how are they going to be convinced of which idea is correct? Well, ideally, what the two people would present to a neutral observer is evidence. If the evidence for both sides seems like it makes sense or it's convincing, then we could compare evidences and look to parsimony, which idea follows Occam's razor more appropriately. Or we could look at contradictions in one of the ideas. If both ideas seem convincing on the surface, if they both seem perhaps equally parsimonious, does one have contradictions within it? That could help us rule one idea out and favor another. Or another big thing would be which idea actually has a working model and is more than just a claim. So we want to know, let's use an example. We want to know why the Earth and the other planets orbit the sun. One person says a purely naturalistic phenomena is responsible for it, and they call it gravity. The other person says, no, it's caused by Spanky, the magic hippo, and his infinite powers. So the gravity proponent, they're able to calculate an uncountable number of successful predictions ahead of time, and all of their equations and explanations are based on known quantities such as mass, motion, etc. This gravity idea also plays nicely with other ancient ideas such as buoyancy. So if we were going to compare this to a puzzle, the gravity section of the puzzle contains pieces that all fit together, and it adds some pieces to edges of previously unfinished parts. And what's cool about gravity is it's so simple that an idiot could understand it. The only people that don't are flat earthers. So if an idiot can understand it and they don't, what does that make them, I guess? But high school kids, they can do gravity calculations and do gravitational experiments with ease, evidence, parsimony, lacking contradictions, and a working model. The Spanky believer has none of this. The Spanky believer comes along after gravity was described and says, no, my Spanky does that. This is what the Spanky believer's idea of evidence is. Gravity believer, where does the gravity come from? Gravity believer, do your equations predict the orbit of Mercury? So the gravity believer, pre-Einstein, they didn't know the answer to these questions. Does this mean that gravity is a false idea? Well, let's check. Has the skeptic added any contradictions? No. Unknowns are not contradictions. Has the skeptic provided a model that can do the same thing? No. They only have a claim. Are they invoking something that is simpler or easier to comprehend? No, a magical hippo with infinite powers is both impossible to comprehend and far more complex. Are they giving us a mechanism that is built on or expands on prior known ideas? No, it just says this thing called magic that nobody knows what it is, exists, and does stuff. So what I think you're going to hear tonight is the alternative, or what you're going to see tonight is the alternative has zero explanatory value because it doesn't contain a working model. I can't tell you how it fixes anything it sees wrong with the current, it can't tell you how it fixes anything it sees wrong with the current paradigm. It makes claims about it, but it can't demonstrate its ability to do or account for anything. I'm right because I'm right because you don't know blank. That's just not how it works. I've never heard an intelligent design proponent give a reason to believe their claim. They give reasons to doubt other people's claims, but they never present positive evidence for intelligent design. Now, for evolution, yes, I am going to talk about evolution. It contains all of the pieces that a neutral observer would want that we outlined earlier. Evidence, yes, genetics, the fossil record, homology, embryology, the geographic distribution of organisms, all of these things either predicted and or confirmed the ideas of evolution, or they make perfect sense in light of natural selection. Parsimony, again, high schoolers are introduced to this, and it doesn't take brainwashing to force them to believe it because it makes perfect sense and is evidence-based. Contradictions, from what I've seen, Sal isn't the type of debater to stoop to saying things like, oh, well, all of the fossils are fake and they were found where they shouldn't be. So I don't really think we need to spend a lot of time going over contradictions, but the skeptics never produce any real contradictions, typically just unknowns. And finally, evolution was really easily falsifiable. The fossil record and genetics would have absolutely disproven evolution, but all it did was confirm and strengthen what we expected. As far as having a working model, well, considering thousands of papers about the topic are published each year with innumerable successful experiments, I would say, yes, we absolutely have a working model. And the final thing about intelligent design that we shouldn't forget is it always was an intentional lie, at least how it was first conceived by the Discovery Institute, and a total scheme that people who weren't content with simply holding their own beliefs in private demanded it be included in schools by pretending that it's science when we know that it's not. And we know that they know that it's not because we have their documents outlining the whole plan. So not only is it not science, but there will never be a world where it even could possibly be science. And you'll have to stay tuned to see why that is. And with that, that is my opening statement.
Thank you very much for that opening statement. We're going to kick it over to Sal in just a moment for his opening as well. But before we do, I want to mention, folks, if it's your first time here at Modern Day Debate, I'm your host, Dr. James Coons. Modern Day Debate is a fully neutral debate platform hosting debates on science, religion, and politics. Don't forget to hit that subscribe button right now as we have more debates coming up in the future. That will kick it over to Sal. Thanks for being with us. Sal, the floor is all yours.
I'm going to share my screen, and greetings to everyone out there. Thank you, Dr. James Coons, and for moderating this discussion, and thank you to my counterpart, Eric Peterson, for being a part of this event. Greetings to everyone this Saturday night on the Ides of March, which is the anniversary of the death of Julius Caesar and my contribution to the slow death of Darwinism. I'm Salvador Cordova. I'm a researcher in the areas of biology, biophysics, and population genetics. I was previously a senior engineer and scientist in the aerospace and defense industry, working for Massachusetts Institute of Technology, Research, and Engineering. I recently published a secular peer-reviewed article in the field of structural bioinformatics through Oxford University Press, and I needed no Darwinism for that. I also, before that, published a reference work in the field of evolutionary biology through Springer Nature, the publisher of the prestigious scientific journal Nature. Speaking of which, pictured on the left is the April 28, 2005 cover of the prestigious scientific journal Nature, exploring the question, is intelligent design coming to your campus? The answer, by the way, is yes. I was honored to be featured prominently in the cover story, and there's a picture of yours truly on the right, as I was featured in that cover story along with ID proponent Stephen Meyer. And let me zoom in on the cover of this edition. It says, evolution by natural selection is a theory, not a fact. Evolution by natural selection is a theory, not a fact. Now, do the editors of Nature really believe that? Of course not. They were mocking Cobb County Public School Board that had put anti-evolution warning stickers on public school textbooks. In 2005, it was fashionable to mock people like Stephen Meyer and others who were skeptical of Darwinism. But in 2025, 20 years later, that no longer is quite so fashionable. And saying evolution by natural selection is a theory, not a fact, rings more true than ever. Case in point, in 2025, famous evolutionary biologist Brett Weinstein said on the Joe Rogan Experience, modern Darwinism is broken. My Darwinist colleagues are lying to themselves, lying to themselves. ID proponent Stephen Meyer is a scientist who is actually quite good. Intelligent design is a component of various worldviews and models of the origins throughout the ages, including, ironically, atheistic intelligent design, such as that promoted by Fred Hoyle. Intelligent design is not restricted to Christian creationism. But speaking of which, Christian creationism, one way to describe it, the way I describe it, is the world is intelligently designed, but also intelligently cursed and in need of a savior. However, the framework, there are other frameworks for intelligent design that incorporate intelligent design. Some accept universal common descent and intelligent design. I will be defending that viewpoint today. So what did Darwin say? In a letter to J.F.W. Herschel, May 23rd, 1861, Darwin said, "The point which you raise on intelligent design has perplexed me beyond measure. One cannot look at this universe with all living productions in man without believing that all has been intelligently designed. Yet when I look to each individual organism, I see no evidence of this, for I am not prepared to admit that God designed." Now, Darwin had paradoxical views on science and philosophy, like many of us do. He noticed organs of extreme perfection and complication. His words from Origin of Species. Yet on the other hand, he wrote once, "What a book a devil's chaplain might write on the clumsy, wasteful, blundering, low, and horridly cruel works of nature." This is similar again to Christian creationism, where you see evidence of design and yet a suffering world. So let's just talk about design. There has been a revolution in biophysics, which I happen to dabble in and study. The Department of Physics, Princeton University, William Bialik, Princeton University National Academy member, he gives this lecture. He says, "More perfect than we imagined, more perfect than we imagined." And Natalie Angier of the New York Times interviewed Bialik. She's a stark raving atheist, by the way, but she writes like a creationist. She said, "Photoreceptors operate at the outermost boundary allowed by the laws of physics, which means they are as good as they can be, period. Each one is designed to detect and respond to single photons of light, the smallest possible packages in which light comes wrapped. Photoreceptors exemplify the principle of optimization, an idea gaining ever wider traction among researchers. For example, the way a shark can find its prey by measuring microfluxes of electricity in the water, a tremulous millionth of a volt strong, which Douglas Fields observed in Scientific American, is like detecting an electrical field generated by standard AA battery, with one pole dipped in the Long Island Sound and the other pole in the waters of Jacksonville, Florida. In each instance, biophysicists have calculated the system couldn't get faster, more sensitive, or more efficient without first relocating to an alternate universe with alternate physical constants. Simon Laughlin of Cambridge University has proposed that the brain's wiring system has been maximally miniaturized, condensed for the sake of speed to the physical edge of signal fidelity. Dr. Emmanuel Todorov has studied how we use our muscles here, and here too he finds evidence of optimization at play. You might say, well, the human body is sloppy. He said, but no, we're better designed than any robot. Many evolutionists believe Darwinian processes, natural selection, account for the designs in biology, but it turns out Darwinism is bass-ackward. Bass-ackward. Why is it that I can now make the claim the dominant mode of evolution is simplification and not evolution toward organs of extreme perfection and complication? Well, the cost of genome sequencing is dropped by a factor of 1,000,000. And here are some titles by the top evolutionary biologist on the planet, Eugene Koonin. By the way, I studied under his staff member, graduate level bioinformatics. Koonin, the title with Wolf, Genome Reduction as the Dominant Mode of Evolution. Quantitatively, the evolution of genomes appears to be dominated by reduction and simplification, punctuated by episodes of unexplained complexification. I inserted the word unexplained. It's not explained. And here's another title, Richard Lenski, Genomes Decay Despite Sustained Fitness Gains. So the translation is so-called natural selection in reality leads to simplicity, not complexity. Darwin's imagination is bass-ackward. And just to give a little hint of why this is so, this lady is equipped for touring remote, desolate environments that don't have a lot of amenities. And whereas this lady's equipped for touring urban environments that have a lot of amenities, such as Las Vegas, Nevada. And so why carry around more than you need for a given environment? We actually see this when bacteria change environments, they lose genes. They lose genes because Darwinian natural selection is really the drive toward copying efficiency. And so the dominant mode of evolution is losing genes. Now, another consideration about the fossil record, I'm going to play this clip by Dr. Dan Stern-Cardinal. He's an evolutionary biologist, a professor of biology at Rutgers. He's an honest to Darwin evolutionary biologist. Let me play this. This is relevant to macroevolution.
On that, we agree. As you said, like we agree that proteins, unlike cellular life, do not share universal common ancestry, right? We disagree about cellular life, but we agree that proteins don't share universal common ancestry.
Proteins don't share universal common ancestry.
So I can give the reasons for that. This is a collagen, the spelling of the collagen protein, and I know I have 1 minute left. And I highlighted the glycine residues in this protein. It's an unmistakable pattern, is definitely non-random. We also have one for zinc finger proteins here. The spacing of these is non-random. They're critical to the functioning. So like the cysteines, the C's here, and the histidines, the H's have to be properly spaced for the zinc ion to park and make this thing work. It is clear that not only is the spelling different, but the shapes are different and they cannot share universal common ancestry. Perhaps in the free discussion, I'll talk about some of my peer-reviewed work on the topoisomerase enzyme, which is a very big problem for Darwinism. Thank you very much, and I look forward to further discussion.
Thank you very much for that opening. Tonight we are doing something a little bit different. So we're going to have 10 minutes where Eric, aka Planet Peterson, will be interrogating Sal, and then vice versa for 10 minutes. So for this next 10, it will be just Eric asking questions to Sal. Thanks very much, Eric. The floor is all yours. Might be on mute. Let me check if you're on mute.
No, that was me. I muted myself and then I forgot I did it. Anyways, thank you. And Sal, that was a wonderful and entertaining opening statement. Your passion shows through. It's awesome. So a question I would have is, what has intelligent design ever proven?
I don't think it's proven anything. I think it's a conclusion. That, by the way, differs from what other people say. Some people say intelligent design science. I don't say that.
So you don't think that it is a type of science?
I wouldn't make that argument. I personally don't think it is. I think it's outside of science, so I wouldn't classify it as science. So using your words, I don't think it's a type of science. It does use scientific arguments to make its conclusion. Now, Casey Luskin at the Discovery Institute will probably fume because he argues intelligent design is science. So does the rest of the Discovery Institute. I do not.
So then what's the purpose of adopting this intelligent design framework? Does it have any practical utility according to you?
I think it will, because there's a field of bio-inspired design, and there are some hypotheses, like in my publication with Oxford University Press, we have these patterns that are non-random, and there are like codes that will help us elucidate protein structure. You can get that just by studying all the species and looking at the spelling of the proteins, and it suggests, I mean, I would not say it proves, but it gives incentive. So I'm not going to be pushing how important it is. I'm more of an anti-evolutionist. I'm sorry if please rephrase your question or repeat it. I probably am not answering it correctly.
Well, I was just asking like what the practical utility or use of intelligent design is.
Okay.
So go ahead. I thought of something, but then I forgot what it was.
So when I mentioned bio-inspired design, it was fashionable until about 20 years ago to say biology is poorly designed because the sickness and suffering in the world. But that view is changing now. Even though there's sickness, death, and suffering, we're seeing machines that have superior optimality. And in fact, it exceeds, if you look at David Hume's work, he said, you look at the design in the universe. Hume was not a design advocate, he was an atheist, but he actually articulated intelligent design very well. He said it seems to exceed human ability. So I see a lot of devices, such as the Bird quantum magnetic compass, that exceed our best. I mean, it's just phenomenal. So if you approach it, at least from a operational standpoint, you may not have to prove it. It's just like it's operationally valid to say the self exists. You can't actually formally prove it, but it's a nice operational assumption.
So
And I would approach intelligent design as a useful operational assumption. If you want to be anal about it, I don't really go there. I'm more of a practical person. So
sure. So for you, intelligent design it's really just a worldview. It's like a personal philosophy. It's not something that can be used to do anything necessarily practically.
I couldn't point to, aside from, notwithstanding what I just said about bio-inspired designs, I think it will lead us to the right way to approach biological systems and make predictions. It puts us in the right frame of mind. Daniel Dennett, who's a Darwinist by the ultra Darwinist, he said biology is engineering. So if you approach biology as designed, you're going to approach it differently. And we're seeing this in the debate of evolution. Dan Graer said if ENCODE, that is the NIH ENCODE project, $1 billion invested, he said if ENCODE is right, then evolution is wrong. And I'm like, well, if we accept the design paradigm that most of the genome isn't junk, it could lead to fruitful stuff. So I could just say again, deciding between the two paradigms, which is more operationally useful, I might accept it just for the sake of argument to move forward. So I'm not going to insist. Oh, go ahead. I'm sorry.
I mean, one literally inspires new scientific research that gets done all the time, and I feel like the other doesn't. I'm just going to move on to my next thing because we're not doing the cross exam for a super long time. Do you have any predictions that intelligent design makes?
For specifically intelligent design, no, but one instance of intelligent design, yes, which is young Earth creationism or young life creationism. I worked for famous geneticist John C. Stanford, who invented the gene gun. His gene gun's, by the way, in the Smithsonian National Museum of American History, and he's predicting the genome will deteriorate. I alluded to it with some of my reference here that the genomes are deteriorating probably across the board, particularly in higher species. So that is, if it's designed, that also means there are more ways to break than to make. If it's designed, there's more ways to break than to make, and that leads to a testable prediction.
Why would that be the case, that if something is designed, there are more ways to break than to make? How does that follow?
Sure. So like, if you look at a password, you can only do it right one way when you're entering it. Now, if you build a car, there might be a million ways to build a car, but there's so many ways to make it not work. We all know that. Okay. Same for the human body. And so as we have the progression and mutations, our prediction, Dr. Sanford and I worked on this we published on Springer Nature on this topic in passing, that even so-called Darwinian selection is not going to be able to arrest the deterioration of the genome. So that would be a sufficient, I think, sufficient evidence, confirmation of intelligent design, but particularly the young Earth implementation. It wouldn't necessarily help the other ones that I showed in my diagram earlier.
Sure, and I think that kind of leads me into my next question. So without bringing up genetic entropy again, I'd rather talk about that in the open discussion.
Sure,
I have a lot to say about genetic entropy, but what would be the best reason or reasons that you would give to believe in intelligent design without appealing to what evolution can't say or answer or whatever?
My favorite is The Origin of Life. And I think even though James Tour does not specifically, explicitly advocate intelligent design, I think his series on Origin of Life has made, he has said a lot of people have started becoming Christians as they've watched his Origin of Life series. And if you're a Christian, that's kind of almost de facto, not quite, belief in intelligent design. Can you repeat your question again? I'm trying to be on target. I sometimes wander.
The question was, what would be the best reasons or reason that you can give to believe in intelligent design. So like positively for intelligent design, this is the best reason that I can give you to believe this, rather than just casting doubt in what the current secular paradigm about life is.
I don't know that there's positive evidence. I would call it circumstantial. So you can, again, my colleagues and ID are going to be pretty upset that I say that there's no positive evidence. I would prefer to use the word circumstantial. I think that's more defensible. I would say it is the complexity of the first cell. Again, there are more ways to break than to make, and the probability seems astronomically remote. And the physicists are saying this is optimally designed on a variety of dimensions. It's, by the way, biophysics is miserably hard. I suck at it because
Probably,
it's so
yeah.
hard. But
don't
that
you-
would be the best. The cell.
Sure, but don't you think that what you're doing is saying there, well, I don't know how a cell is too complex to have arisen this way, therefore intelligent design. Don't you? To me, I see a massive leap there.
It's a massive leap, but whether it's a massive leap or not, I would just say what we know about physics and chemistry in the ordinary normative operation, it's not consistent with that. And I mentioned atheistic ID. Yep. Fred Hoyle was a big advocate of that, and he was the one that gave the tornado in the junkyard that definitely applies to origin of life. And he was invoking other mechanisms that are very speculative, kind of like an intelligent universe, and they have anthropic principles that were followed on by that. So I think saying we don't know for sure is probably, we have the Heisenberg uncertainty principle where we say we have limits to our knowledge, same with Gödel's incompleteness. So we might say that, I think it's too much to say we're figuring out the origin of life. And I think that's too much of a promise. I think saying I don't know is probably fair, but,
that's fine.
It's more believable than others.
What I typically say about this is I don't know where life came from either, but when I look at life, I'm gonna say something, then I'll just ask if you think it's a fair or reasonable inference or whatever. When I look at life, I understand that literally not a single thing about what any living organism does is a miracle. A miracle, there's no literal miracle that occurs when the DNA is copied, when the cell splits, when carbohydrates are broken down. So I don't understand invoking a miraculous origin when we know that the operation of life is literally merely chemistry. Now I can offer you only a very low resolution naturalistic explanation. Chemistry is where life came from, because that is all that life is as we understand it. So just I want to try to ask one or two more questions. My time is running out. So I just want to get your quick take on whether you think that's a fair assessment.
That is a view that a lot of people hold. And the problem is I would agree the operation of life, I would use naturalistic methodological naturalism for that. I have no problem with that. But it's the origin of life. When you start to study at the biochemical and biophysics level, you're just like, how does this happen? And I again point out to some atheists that are noticing this, and they're saying, we despise the creationists, but the probability calculations are reasonable. Probably the most astonishing thing, I mentioned Eugene Koonin as the top evolutionary biologist. He weighed in on the origin of life problem, and he said we need multiple universes to even implement the first cell. I mean, philosophically, he's totally on the opposite side. But as he tried to do an analysis based on the chemistry, he said, the origin of life researchers are wrong on this. So he's not quite as known as James Tour on the stage of this debate, but it's not like people on your side of the aisle have not noticed their problems. And actually, people like Fred Hoyle, Eugene Koonin have actually contributed a lot to intelligent design theory because they're less biased than I am.
Sure. I think this is probably the last one I have time for, though I'm not totally sure. But if evolution was true, what do you think the evidence would look like?
So the common descent looks very compelling. That's why we have ID proponents like Michael Behe. So it is consistent. The nested hierarchies, to some extent, are consistent with that. and it would not have anomalies like the one that I pointed out that Dr. Cardinal had to finally concede after 4 years of us talking about it, that there can be no common ancestor for all major protein families. That really, I think, makes a wrinkle. So you would have to eliminate that problem. You'd have to eliminate a lot of the complexity, because biology is too rich in complexity, and that goes into some population genetics that is really complicated. It's not that complicated, but it'd take me about an hour to explain it. So,
but what would the evidence look like? Because you're just picking out something you think is a problem, but what would the evidence look like?
I'll give you a chance to answer Sal, and then that is actually the conclusion.
Yep.
Well, that's fine. Thank you for giving him extra time. This is a great opportunity to try to. It would look like it did to Darwin in the 19th century, really simplistic, and not like the data we have today. In the last 20 years, the data we have today is making it really difficult. You'd have to ignore the data. So it would look like kind of our simplistic viewpoints, just looking at fossils and not seeing the molecular evidence. We'd have to ignore a lot of it. And that's why I think Brett Weinstein, who is an evolutionary biologist, and they're more like him actually, either out in the open or closet, saying Darwinists are lying to themselves. He said, I get annoyed with my colleagues. Modern Darwinism is broken. And he's seeing that there are problems in it. He's not the only one. And he's not referring only to just Darwinism. It's their evolutionary biologists are recognizing their problems as more data has come in. I know that because I reference a lot of their work to make my arguments. A lot of what I've made here in my opening was I tried to reference what they themselves have said.
Okay.
By the way, thank you. Those are great questions. I appreciate your inquisitiveness.
We'll switch it over, and same thing. We'll give you about 11 minutes, Sal, as we went a little bit over. The floor is all yours to ask questions as well, Sal.
Okay, so I don't want to be too confrontational. I mean, I really like Eric here already. So I'm just going to talk. I'm just going to ask some questions here, and there'll be a back and forth. I want to just show you. This is a topoisomerase enzyme on the, this is the way it's shaped. I don't know if you can see my pointer, and on the left is the way that it's spelled. Dr. Joe DeVries, who is one of my co-authors, he was published in the prestigious scientific journal Nature. He's also an ID advocate and a creationist. He and I had, that's him right there. He has this beautiful talk on the Discovery Institute channel. I encourage all the viewers to see it. You can see how a creationist, biochemist and professor of biochemistry can articulate the design argument very well. He and I published in creationist journals together. And we also, he's, like I said, he published in the world's top journal on topoisomerases. We both published in the Federation of American Societies for Experimental Biology on stuff on the topoisomerase. Recently, we published in Oxford University Press. And so this is not so much a question. I'm gonna field the question after I show this. So you have a man-made pair of scissors here on the left, and on the right you have a God-made, I call it God-made scissors. Now these scissors cut DNA. Topoisomerase 2 alpha is and also beta are targets of chemotherapies, because if you kill the topoisomerase or disrupt its function, it will kill the cell. Unfortunately, chemotherapies kill good cells too. Part of our work was trying to find out how we can maybe get the topoisomerase to be targeted that is only in cancer cells. So this topoisomerase here is, it has to untangle DNA because DNA gets knotted. The way it untangles it is it first cuts it, and then it does what they call a passing maneuver to untangle it, and then it reconnects it. The problem here is, how can a partially formed, so earlier the question is, what would evolution look like, that Eric asked, if it were true? I said it wouldn't have things like topoisomerase, because the ability of topoisomerase to cut and then untangle and then reconnect, just consider this. If it cuts but doesn't reconnect, it cuts but doesn't untangle, the creature's dead. If it could reconnect, but it can't cut, the creature's dead. Could reconnect, but it can't untangle, the creature's dead. If it could untangle but can't reconnect, the creature's dead. If it could untangle but can't cut, the creature is dead. This is the problem of all or nothing. And this is the problem for Darwinism, and whether something can evolve in gradual steps. So when I see all these claims about the fossil record, I don't see it being able to answer problems like this. So the question I'll pose to Eric is, do you see any problem with my analysis here? Why this is, I think, a showstopper for Darwinian evolution?
Not really, because this sounds like exactly the same problem that Newton's classical equations of gravity had with Mercury's orbit. It could explain countless things, but there were some particulars that it couldn't explain. But that doesn't disprove the other things that we already know, especially since no alternative mechanism has been produced here. But just because we have this protein, this topoisomerase, that performs a very particular and complex function that has to, occur in a specific way, I don't see how evolution could not have done that. I may not know how it did it, but I don't see any logical problem or anything with this.
Oh, I appreciate your.
I do have a little more to add there.
Oh, please go ahead.
Because I've seen you talk about this before, and you talk about how topoisomerase is you can transfer it from human to yeast, but not the other way around. But we don't do it with humans; we do it with mice because we don't experiment on humans.
First of all, sorry to interrupt. Thank you for watching that. I appreciate you reading my stuff. It's better to be criticized than ignored. So thank you very much.
No problem.
Adding YouTube views to my channel. Thank you. So
the idea of being able to, I don't know what you call this, not transpose, but like to take genes in one organism or proteins or whatever and have them work, I suppose, do they do it by relocating the gene to the yeast, or they just introduce the proteins into the cytoplasm?
Okay. Joe DeWeese, my co-author, was the one who had cited that. I'm almost 100%, I would say 90% sure that they did genetic engineering.
Okay, that's what I would think, right?
Genetic engineering.
The interchangeability of genes, I think, actually makes sense under a common descent model. I don't think it's contradicted by it. Now, I do know that one thing you bring up is, well, but there's only a one-way transmission. But to me, it would make more sense that you can't take the more simple organism, the yeast. When we try to bring the yeast gene over to the more complex eukaryote, the vertebrate, like a mouse or whatever, it doesn't work. But a mouse is more complex than a yeast. So to me, intuitively, and maybe I'm a dummy or something, but intuitively that actually does make sense to me, that the simple gene to the complex organism works a little bit better, whereas the complex, the gene from the more complex organism doesn't work for the simpler one. Because if it's a simpler, less highly derived organism, like yeast aren't, we get into, I don't want to get into this thing about like it's a more ancient organism, but they do evolve over time as well.
You can use that sort of language around me. I've been around evolution.
No, I know that you get it. It's just, it's tangential and it doesn't make the point that I need it to. But I just would say, for me, the mouse is a more derived, it's a more modern creature, for lack of a better term, than the yeast is. So it does make sense to me that there's only a one-way transmission there, if you will.
Okay, so I do have the view that there is a progression, unlike a lot of creationists. I also think even young Earth creationists, I think we're very, very similar to chimps. So you'll never see me arguing with someone like Gutsick Gibbon. I don't know if you know her, Erica Gutsick Gibbon.
Yeah, I know her. Yeah.
Yeah. And that I also argue that there is a progression from all forms, from simple to complex. You can take a collection of organisms from prokaryote to human, and you can arrange them in the order of complexity. And then also some of these things like the transferability of specific genes. So, but going back to what you said about topoisomerase, and I'm really not trying to pick on you specifically. I do know that as I talked to Joe and we had analyzed the literature on topoisomerases, we actually laughed. We laughed when we read what evolutionary biologists were saying. And it's like, well, you could say that you believe this, but it's not an experimental fact. It's not theoretically proven to the standards that I see when I've studied physics or engineering. So you could, I don't have a hard and fast definition of science. I think there's a continuum where you have, at the very top tier, you would have experimentally confirmed. And then kind of at the lower tier would be speculative and like, this is a good hypothesis. We may or may not be able to test it. The issue I have is if we are trying to communicate that this evolved and then the answers are, we don't know. It's like, why don't you just say we don't know rather than what I'm seeing is that there's this cultural trend to say that if you don't believe it, you're not pushing science. And I'm like, well, look, you just collectively, I've seen the literature say on the origin of various proteins or these systems, especially eukaryotic transition from prokaryote to eukaryote. They said, there's one thing, there's this article, The Long Winding Road to Eukaryotes. They said, we'll never know, we'll never be able to prove our hypothesis. And I was like saying, okay, I appreciate you saying that, but then that means you shouldn't, collectively the evolutionary community shouldn't be pushing this and insisting we believe it. And that's the problem I have. So, do you think I need to believe in evolution to be able to function as a biologist or biophysics researcher? And I'm running out of time. I have a minute, 15 seconds. I have a serious problem with that because we have very fine minds like John Sanford, Joe DeWeese, Darwin skeptics like James Stewart. It's like, I'm seeing more and more of them matriculate, and I don't think it's fair to be insisting that they believe it. I insist that they study it. They need to understand it to be literate, but they don't have to believe it. So that's a long way of stating my question. I'll try to be more succinct. Apologies. Do you think we have to believe it to be good scientists in biology?
Well, I find that to be a little bit of a weird question because you guys do believe in evolution. I'm pretty sure most of you even believe in natural selection. You deny that it goes as far. You don't believe in natural selection?
I believe it's bass-backward to the way it's advertised. As I said, it leads to simplification, not complexification.
Okay, well, yeah, I'm happy to talk about that in open discussion.
Sure.
I remember you saying that. But you guys believe that evolution occurs. You just don't agree that it goes as far as we do. Like universal common descent all the way back to prokaryotes or whatever the first form of life was. So I like, even if you don't, I just find it weird because no, you don't need to accept it, I guess. But what I mean by that is you don't need to accept the links you don't need to accept it plus the conclusions that people that think the earth and life are billions of years old, like myself, do. You don't need to accept that, but you still use it as an operational framework to understand the stuff about life that you do believe.
Well, that was my last question. We can go into free discussion. Thank you for humoring my queries.
No problem.
This is actually the time that we will go into open dialogue. Folks, if you happen to have questions, you can feel free to submit them via the live chat if you tag me with @moderndaydebate. Otherwise, if you'd like your question to go to the top of the list, you can submit it via super chat. And that allows you to make a comment as well, so it doesn't have to be in the form of a question if you use a super chat. With that, gentlemen, thank you very much. The floor is all yours for open dialogue.
I kind of want to talk about the genetic. I definitely want to talk about genetic entropy, but I don't know if I want to talk about that first because we may spend a long time on that. I want to try to get to some other things that I think will be shorter, if that's okay with you. But
actually, I just wanted to say I'm probably more in the mode that I'd like you to ask me questions than hit me hard.
That's fine.
It's better to be criticized than I'm not here to beat up on you or anything. I'm actually, as you ask me questions, it gives me an opportunity to promote my work. So a little bit of shameless advertising. And plus, I do appreciate your curiosity about my ideas. I'm sincerely appreciative of that. So, I'm not I'm not really
Sure.
in the mode tonight to badger you with questions and gotcha stuff. That's just not who I am.
That's
Yeah, get to it.
Anyways, well, I think he was directing that at you. But the problem I have with design that I tried to lay out in the beginning is it doesn't have like a working framework. And so I just can't see why anybody would be pulled to that side. And instead, all that's done is like trying to sow doubt into things. So for example, for the topoisomerase protein, whatever it's called. So I get what you're saying, that we don't know how it ended up being, like, it's very finicky in complex organisms like us. We don't know how it could have gotten that way. It's almost like an irreducible complexity argument. However, I do know that you can run like the BLAST sequence for that gene. And yes, in us and chimps, the gene is actually identical between the two of us. I don't know of a ton of examples like that. I'm pretty sure our hemoglobin gene is identical in chimps.
I'd estimate it's 95, 98% similar. There are like the cytochrome C, I think, or the oxidase is 100% identical. So by the way, to creationists out there, stop using we're so dissimilar from chimps. We're very close to it. So just, I'm kind of affirming one of your points there. So I'm sorry, I cut you off. Please.
It's fine. But anyways, when you run the BLAST sequences for that gene, it breaks down in similarity, or rather it breaks down in similarity across taxa, just like what we see in genetics. It's most closely similar with the great apes, and then less so with other mammals, and far less so with different kinds of vertebrates like reptiles and birds, which were not closely related to at all. So to me, this is an example of this is sort of cross-disciplinary, because it's not exactly the same thing. Well, not really, because it's genetic, I guess. But if the design thing is really what's going on, if it's not down to evolution, then I don't think you can find a correlation as you go down, because if it's something else, then the multiple different predictions made in the secular paradigm, they have to break down. But when those predictions and when those similarities keep happening at multiple different levels of analysis, then that's way too extraordinary of a coincidence for me to be able to just hand wave away.
Okay, so there is, I'm looking for a picture here, and I'm going to share it because I like graphics to just kind of frame discussions, and I'm just going to share it. I mean, I could describe it, but I kind of like, I really kind of like good graphics. Let me see if here's one. Let's see if I could find, here's my favorite one. Hang on. I apologize because I'm doing this on the fly. That's one of the challenges with the free discussion. So I'm going to share my screen here, and it does accord. I'm trying to indirectly address. So can you see that bent pencil there?
Yep.
All right. So the issue is we could look at the same data and conclude two oppositely different things. We could either say the pencil is bent or it's not. So if you look at some of the data, you can definitely say, hey, look, this is bent. But a more careful examination of the data and it took actually thousands of years before people figured this out, and it was codified by Willibord Snell and Snell's law, that it can look convincing and agree with prediction, and then it begins to fall apart. So with the issue of this nested hierarchy, so you're describing like if you don't mind me using that word, because I've seen it, that was a problem for me when I was starting to debating between creationism or non-creationism. So again, Michael Behe accepts common descent, but he believes in intelligent design. He was an inspiration to actually a lot of creationists, but he actually believes in common descent. So one thing that was persuasive to him is exactly what you said. The problem is what evolution didn't predict was all these protein families that don't have any ancestry between them. And some people on my side, like Paul Nelson, are saying this is going to be a difficult problem because some proteins, not all, are so complex. You're just like, well, they have to kind of all be there at once, as far as we know experimentally. And so natural selection has no route to building it. And then they're so complex, natural random mutation can't construct it. So, it's like, well, that's not really predicted by evolutionary theory, because it just kind of like pops out. So I showed the collagens, which appear in metazoans, and I'm not really a taxonomist or an evolutionary, phylogeneticist, but those are, without collagen, you don't have bones and skin. So a lot of taxa that don't have that complex thing, it just has to all the way appear there. And that's kind of difficult to say, yeah, maybe the organisms in the fossil record looked like they had this gradualism, but then it's punctuated by this pop out of complexification. So I cited the paper by Wolf and Koonin that said, genome reduction is the dominant mode of evolution, but then it's punctuated by episodes of complexification. And it's like, well, how is that really different than special creation, except you're just saying, well, we don't know what the mechanism is, but it just happened. I think a credible theory has to be consistent with physics and chemistry and probability. That just is not consistent. So it's like the bent pencil. On some level, it looks consistent. And then you look at these protein families and are like, well, where did that come from? And that's why you have ID proponents like Michael Behe said, we'll accept common descent, but what do you do about these complex proteins?
Well, I mean, there may be things that we don't know, but I don't think that discounts or disproves any of the other information that we have. Because again, the thing with genetics, and even that topoisomerase, that's a genetic analysis, but it correlates with what we thought, because before we could do genetics, we just had taxonomy, which was kind of a science, kind of more of an art form. Well, I wouldn't say more of an art form. It was systematic, but it's a little bit subjective. And we didn't, ultimately we create these categories. Linnaeus started doing it, not out of total arbitration, but, there's some subjectiveness to that. But we classified the organisms based on appearances and anatomy. And then when it came time to, when we figured out how genetics works, it was time to put that idea to the test. And we get the same nested hierarchies when looking at these proteins that you, like the topo one, that there are things about it we can't explain, but we see the same kind of hierarchy in that we do with the classification system and with the genetics overall. And so I think that's just way too marvelous of a coincidence to say, yes, but the other underlying things embedded within this that we don't understand cast doubt on the entire thing. I just don't go that far. But another thing, kind of change subject, but stay on the same.
Well, if I could finish out that
Yeah,
thought.
go ahead.
So my problem is, what if someone says, well, I don't think that is, to me, that's, if I said, that's not believable. And there are probably lots of students of science, because I know them, because they end up going into medical school and they have to study biology. There's kind of a resentment that they have to accept this as fact. I don't have any problem if they have to answer a test question. I've answered test questions where I knew the professor was wrong on the matter of physics, but I said, look, I don't view it as lying to say, entropy is disorder, even though I know it's not. But that's what he was expecting as an answer. So I do have a problem if we're insisting this is, require a requisite to succeed in science is to believe evolutionary theory. I think it's important that they study it. I would like creationists to learn evolutionary theory. Maybe that's perhaps about the only area we could agree on. Finally, if the Earth is young, this is what I tell young Earth creationists.
I have to butt in. My smoke alarms are going off. I will be back as fast as I can.
Okay, can I dialogue in the meantime, James? He won't hear me. So, James, I can't hear you. Oh, you're muted, James. You're muted. Why don't you advertise? I'm sorry.
One thing I want to do is we will give Eric a chance. Hopefully everything is okay over there. That's scary. So hopefully everything is okay with Eric. And we do want to remind you folks, a couple of things. First, our guests, Eric and Sal, are linked in the description box. So if you would like to hear more of their positions, I'm sure we're probably going to continue the debate. Hopefully, it's just that maybe someone left the popcorn in the microwave or something, hopefully. And we'll probably continue the debate. It's safe to hang on. However, in the meantime, I do want to do a couple of quick housekeeping things first. Both of our guests are linked in the description box so you can hear more where that came from. Also, thanks for your super chat question. This one just came in from plant-based, based in all caps. We have, I think, maybe about a handful of questions. So we do have more questions that we can take for the Q&A. And we also have housekeeping stuff such as, if you have not yet, folks, hit that like button. We do appreciate that. It is seriously a personal favor to me, as I really do believe, based on looking at the YouTube analytics, that it actually does make a difference, that videos with more likes do get more exposure. And maybe you're like, well, but what's in it for me, James? I don't care about doing a personal favor for you. Well, I would say this. The video would get more exposure. So if you think that your side is being more persuasive in this debate, then it is in your best interest to hit like, as that means more people would see your side winning in a debate if you hit like, as YouTube will show it to more people. Now, Scummy in the live chat says, why am I blocked? Scummy, you are not blocked. I can see you asking that question, so you're definitely not blocked. And how's your life going, Sal? It's been a long time since we've hosted you.
Oh, it's been insanely busy. So we'll talk about things that, Eric won't have to worry about because it's not debatable. My health has improved, and I am been accepted to a PhD program in biomolecular engineering. I have 5 science degrees, now working on a 6th. And I don't know if they're going to give me a master's along the way that would actually make it 7 degrees. I'm actually getting really old. I'm going to be a senior citizen. And, so what else? Okay,
You're
how's
aging
my
so
life going?
well, Sal. I never would have guessed. You have,
I'm 62, bro.
your skin. What's your skincare routine, Sal? You look fantastic. Good for you, brother.
We were talking about skincare here, so it's don't worry about it, Eric.
I'm back.
Everything okay, Eric?
Nothing even, nobody was cooking food. There's no candle burning. They just started going off, and I couldn't, they just stopped.
Hey,
so they
good.
may start up again because I don't know why they even started. I hope not, though.
That's a good false positive then. I'm glad to hear that.
Yeah.
Oh, I was a little scared. I was like, it doesn't happen often. I'll give you guys a chance to jump right back into it. Yeah, we were just making small talk while you were out. So nothing has continued in terms of the dialogue. Go ahead, Sal.
Okay.
Oh yeah, so he's asking me how I'm doing, and well, there was
I do remember what we were talking about. Because you said, why should people have to accept the secular paradigm or whatever? Why can't they just reject it or whatever, right?
I was saying I don't like it being a litmus test, even maybe not specifically university, but culturally, to be labeling these people as being inept to be able to do science. I think one that will hurt science, because there are a lot of medical doctors and scientists and biochemists and biophysicists that I can tell you, I meet them privately. Some of them have graduated Harvard and Yale, and they don't believe in evolution, and they're doing very fine, but they have to be quiet about it. I don't think that's conducive to moving. I mean, we need, the more scientists we have, the better. We may disagree on things, and I'm just saying, I'm not talking about anything formal, but I don't like that attitude. On the other hand, unfortunately, I do have to say sometimes the creationists have brought it on themselves. Sometimes they're just too polemic about all this, and I think they've hurt themselves a little bit on that. So, I mean, there is some blame on our side too for the state of affairs.
Sure.
So,
okay, well, just
so I did want to say young Earth creationism. I threw that out there. I was trying to say, if the Earth is young, or if the life is young, let's say the Earth is old and life is young, there are some models of young Earth creationism. They're not really young Earth creationists. Some Seventh-day Adventists will say, well, we're not committed to the age of the Earth, but we are committed to the fossil record being young. If there's empirical evidence of that, which I'm starting to believe there is, it's getting stronger since I've been monitoring this debate for 40 years, then the pattern of similarity, the nested hierarchies are by common design rather than common descent. And the paper published in Oxford University Press would actually support why there's common design. It's actually optimized for scientific discovery. The nested hierarchy is the consequence of the codes that are written for us to be able to discern protein folds, and it's really complicated. I'm sorry, this is like an hour-long talk. It's probably not worth it. We're going to bore the audience to death. So go ahead, fire away, Eric. And by the way, I'm glad you're okay. I'm glad your house isn't burning down.
Yeah, me too. I'm just glad that the stupid things finally shut up. But anyways, but I think a problem we have here is that we know what structures similar by relation look like, because we do that with, I mean, we do pedigrees of, we do them with humans, we do them with dogs. And like, you can say that, I mean, like if you reject evolution or whatever, you could say like, well, when you compare a human and a chimp, you're implicitly implying or whatever that they have a common ancestor. And it's like, well, I mean, but we implicitly assume that with humans, and it works kind of all the same. Now I bring that up because we have no idea what structures, or sorry, what similar structures by design look like. Because if we actually think about how this works in the world, related structures, they fit inside the hierarchies. They're similar by relation, talking about genetics here. Whereas designed structures, if we just imagine designed structures, they're independent creations. Commonly designed things actually share almost no parts between them. I mean, you take an Airbus and like a little crop duster airplane, they're going to share nothing in common, maybe except for some screws, but they're both airplanes, right? Whereas you take an albatross and a hummingbird, or a blue whale and a bumblebee bat, the biggest and smallest mammal, and the amount they share fundamentally is vastly great. So much more so than two things that have the same function, flight, and are designed. Whereas these two mammals, they breathe air, they have diaphragms, they give birth to live young, they lactate, but there's not a ton they share in common, but fundamentally we classify them both as mammals, and then the genetics predicts that nested hierarchies, they need to be more similar than anything else. And that's what we see. And there's just no mechanism for weeding out or identifying commonly designed things. I don't find there is anyways. And I can actually show some paradoxes or contradictions with that in a little bit, but I want to let you talk first.
Well, if the Earth is, if the fossil record, if life is young, there's just not enough time. I've posed that question to some evolutionists. They want to dodge it. I'm just like, look, you and I know the change of rates of evolution for genes or whatever. You know, this would have to be independent origins. So, you know, this is where I'd say, look, young Earth creationists, don't go to the genetics. That's not going to solve your problem. I think people like Eric would have their point on you for trying to do this. I keep saying, stop arguing genetics, because you're going to lose. You need to argue the age of the Earth if that's what you're insisting. Otherwise, he would have a point. That's exactly why Michael Behe shares half of Eric's side here. He believes in he would accept common descent. If you look at Darwin's Black Box or any of Michael Behe's writings, rich with common descent arguments. So as far as common design, I'm just going to turn this around. Homology was a term coined by Richard Owen, and he was kind of a ID proponent, quasi-creationist. It's ambiguous whether he believed in common descent or not. He was the one who invented the word dinosaur. He's the one that invented the word homology. And homology was similarity based on a master plan. And if you look at some of the last of his writings, it reads like an intelligent design essay. So to flip this on its head, operationally speaking, in terms of being a surgeon or a medical doctor or someone making medical advances, what difference does it make if it's common design or common descent? The issue is whether it shares similar architecture. And that's why we could also turn this around and say, well, what use is evolution to advancing modern technology? What really counts is the architecture and its operation, its structure and function, which is, by the way, another word for design. So if you don't want to accept intelligent design, you could say it has the same, at least the same architecture and same build. It doesn't matter whether it was plagiarized by a common, by God, copying the same design as Owen would postulate, or whether it evolved by common descent. It's not essential to modern science. It's certainly not essential to biophysics.
I don't know like what I'm supposed to say in response to any of that, I guess. But what I'm trying to do is show that intelligent design, it may have predictive powers, or like there may be things we can look to. Like there are assumptions in it, and these assumptions are kind of testable. Like if you believe the genome is designed, and the reason that organisms have genetic similarity, within the same family or whatever, is because of design. Well, we can test and see where that can kind of fall apart. Sal, can you see this critter right here?
I can barely see it. There's a ring.
Yeah, that's my ring light. Can you see that critter?
Yes, I think we all can see it. Thank you.
What do you think that is?
I have no clue. That's way above my pay grade as far as taxonomy, but thank you for sharing.
Well, it's a marsupial mole. Hold on, my camera will come back. So it's a marsupial mole. It lives below ground. It has a lifestyle and a physiology just like that of moles, meaning it barely has eyes at all. It has extremely broad and strong front limbs. The hind limbs are kind of weak and wimpy. But so a marsupial mole, outward appearance wise, design wise, we could ask the question, what's it more similar to? A true mole, which those live in Africa, they're insectivores, is not a real group, but whatever. Or so what in terms of design or whatever, what's it more similar to? A true mole or a kangaroo? Well, we would all say it's way more similar to a true mole. But genetically, what's it more similar to? A mole or a kangaroo? It's vastly more similar to a kangaroo. I really don't see how intelligent design can possibly deal with this. If the genome has to be designed because it produces, like you like to look at the micro level and look at things that it produces that are too complex for any other kind of explanation. But it's really fundamentally the core, it's the blueprint for the entire organism, everything about it. So if form follows function and the genome is designed and it's what produces these organisms and how they look, then how on earth do we end up with organisms of such incredibly similar design that are not at all closely related? They're so much more closely related to things that don't look anything like them. Descent with modification, I think, makes sense of that because taxonomically they're both marsupials, whereas the design one, I think this is a test that it just fails.
And I don't see it that way. We actually think convergence, which you're describing, where you have marsupial moles versus placental moles, share very similar. And you also have placental dogs, which is the typical dog. Sadly, the marsupial dog is extinct now. We have one photo, I think, or a couple of marsupial dogs. They don't exist. There are also marsupial squirrel-like things, and then
there's
placentals.
Tons, there are cat-like
so
marsupials.
We think convergence is actually evidence of design. It's just kind of like an insult to evolutionary, because it has common physical architecture that's similar, but it's not it's not of totally genetic origin, because placentals and marsupials are supposedly had split. But if I may share something, I just for the sake of the interested readers out there, if you have 30 seconds here, I'm going to share something that you could look up on Wikipedia. You can kind of see my perspective on things and some of your discussion here. This is advanced stuff. If you look at this entry on direct coupling analysis, I was talking about the common design, the patterns of diversity and similarity. With this pattern, we pump it through the sequence differences. So, you have the amino acid sequences, you saw the letters, you pump it through this math, and you can actually create the shape, you can predict the shape of the protein. And that evolution has no explanation for that. And I think it's a conjecture that nested hierarchy is a consequence of a design. And this is a future testable hypothesis. I don't know if I have the time to actually pursue it. And I'm sorry, it's so deep in the weeds and really esoteric. But there are people that I know personally, they're publishing in the top tier journals on structural bioinformatics, which I also published in, that don't believe in evolution, but they believe in this, and they're being able to make advances in
Sal, what did any of
biology.
that have to do with convergent evolution?
I switched the topic.
Oh, okay.
I'm sorry. My apologies then. But I felt I was just, I wanted to just throw that out there that there are patterns. Even if you accept common descent, you're going to have problems like, how did this pattern arise? Because one thing, when we're doing protein structure predictions of the 3D shape, if you remove the plants from this database and it's doing this calculation, the shape prediction will fail. It's like, that's kind of like, that's like voodoo. Why would it work that well unless it were designed? There's also one problem that I didn't mention that's going to be way more severe, and I know the convergence problem. So let's say we disagree on the convergence problem. One problem that when I present this to my colleagues, we actually laughed at evolutionary biologists, because when you have one protein in one organism and then you have the homolog in another, when you change some of that sequence, and we're talking about sequence similarity, like say the zinc finger proteins between chimps, or let's say some other primate and a human. When you change that, you have to change so many other things. We're finding this out. And we laughed when I said, look, they're predicting coevolution. And we were all laughing because it's like, do you know how difficult that would be for the odds? This is like changing a key and then expecting locks to simultaneously change to be able to match that key. And this is like, that's just between one interaction or binding interaction. When you have multiple ones across numerous proteins, this is going to be a nightmare. So if you're just, modeling this as an evolutionary walk that's driven by random mutation, and maybe even some selection, it's just not going to work. I'm predicting, this is a testable prediction, this is going to be a difficulty that they're going to face in the next 10, 20 years. And I think Brett Weinstein was right when he said, Darwinists are lying to themselves, because this is not going to get fixed. I could already foresee that. So, I know this is deep in the weeds. It's really esoteric, but people in my field see it. It's so clear.
Okay. I think we should probably talk about genetic entropy, because it's kind of a whopper of a topic.
We have time to do that. Though this will have to be our last
talking,
topic.
But he's muted. James, you're muted.
Oh yeah, sorry, folks. I forgot.
You're
There's
still
always
muted.
the two mute buttons. So there's Zoom and there's OBS. We do have enough time to go into that topic, but this will probably have to be our last topic before the Q&A. So I'll give you a chance to jump into that. Eric, go ahead.
Yeah, no problem. So I have a lot of problems with genetic entropy. One is that it's built on this assumption that most mutations are harmful. And that just isn't true. I'm curious as to what your take on that is.
Okay, so I just for the record, I worked for Dr. John Sanford, who is the pioneer of genetic entropy for 7 years. And so one of the problems is how we define evolutionary fitness. There is known literature by evolutionists themselves that point out the problem that fitness, the way the evolutionists define it, there's a problem with it. It's not very well defined. And if you will just do an generative AI search and say, evolutionary fitness, why is evolutionary fitness ill-defined? It'll actually agree and say, well, it's ill-defined for these reasons. So when you say the word deleterious or beneficial, it just means whether it increases, beneficial is you're increasing copying efficiency. It's more fit. Whereas deleterious means it's less copy efficient. So that's why you can have situations where genomes are decaying. And we had that experiment that I cited by Lenski, where the genome decays, meaning it loses genes, And yet fitness is increasing. Fitness, evolutionary fitness is increasing.
I don't see a problem with that.
That is a serious problem.
No, I don't see a problem with that at all.
I absolutely do if you're going to try to explain the origin of complexity, because this is showing that Darwinism is going backward. So this is the testable experimental prediction.
It can't go backwards. There's no such thing as de-evolving. Just because a genome, like a population genome, will reduce in some of the alleles, that's not going backwards or anything like that. Because even if you reject Darwinian natural selection or whatever, you can still analyze the argument on its own merits. Selective pressure comes from the environment. If the environment is stable, then there isn't added selection pressure, right? I'm going to kind of build a case here for this.
Okay, so you said most mutations are okay. So I'm first pointing out there's a problem with the definition of deleterious.
I'm dealing with what you're.
That is a serious problem, and I'm not. It's not just because creationists are saying this. Evolutionists themselves have quietly said this. That would include Richard Lewontin, who's a very senior. He's passed away, but he's a very senior evolutionist. Andreas Wagner, and there are probably some others out. So I'm not. I'm not out on a limb saying
you referenced.
I'm not out on a limb.
I know, but you referenced Lenski, and all he talked about in his experiment, from the quote that I heard you say, is that the genome, in a way, is simplifying. There's a little bit. You start off with a genome, like we can imagine, like a language, like two people. Maybe two groups that have slightly different languages come together, and at first it's a blend of both the languages they speak, and it's really complex, but over generations it actually simplifies. They delete some words from the lexicon on both sides, and the language becomes a little bit more simplified. The Lenski quote you were giving me sounds just like that. The overall genome, it's becoming a little more simplified. Assuming I got that right, but this is why I don't think this is a problem.
I wouldn't say a little more simplified. It lost complex genes like DNA repair mechanisms. Well,
in the lab, that's what was demonstrated, but natural selection is very much removed in the lab is part of that.
Well,
that would be a perfectly acceptable explanation for what's going on there. But I'm trying to build a case on something here, which is that.
Look, you're a nice guy, and I'm sorry I have to be throwing cold water on your attempts here, but I just feel like I have a professional responsibility to say you have to look at what experiments we have. That's the most comprehensive. And if we're seeing in our lab experiments that genes are losing faster than they're adding, that should be really disconcerting.
No.
The other thing is too, we're actually we're seeing that out in nature outside of the lab, loss of genes starting. Yes. How can you build a microbe into something as complex as a human when selection is
I've been trying to tell you for a while.
I interrupt you. Go ahead, please.
So if the environment is not changing, then there's not added selective pressure. So if the environment is stable, then we get to something called stabilizing selection, where natural selection favors the organism that has, like, the average fitness works very well. Kind of like a if it ain't broke, don't fix it type of thing. Once disruptions in the environment or changes in the environment open up, then that's what can introduce selective pressure. And then we can go into either destabilizing selection or directional selection or whatever. Now, if environments are stable, it wouldn't be a paradox or a contradiction to, because of stabilizing selection, to expect that organisms would become a little bit more homogeneous thanks to natural selection. What happens, though, and we have historical examples of this, which you can reject, but we have real-world examples of this I don't think you can. What happens when an extinction level event happens? Well, now all of a sudden, niches open up. When the dinosaurs went extinct, birds and mammals exploded in diversity, filling in niches that presently there weren't selective pressures for them to exploit. So radiate, I don't know what the term for it is, like radiating evolution or something like that. But when a niche opens up now, all these variations can be exploited, because if an organism is constrained and trapped within its niche because it shares that environment with huge numbers of other organisms, and I can't remember what it's called, but the concept that no two organisms can share the exact same niche. Shame on me, I'm forgetting what that's called right now. But if that is removed because of, for example, extinction level events, then now all of a sudden an organism that is slightly different can be driven into a new niche that was previously occupied by some other organism. And that is what's going to allow for genetic differences to accumulate and multiply. And then that drives speciation in that case. And we see that kind of thing in the fossil record. I don't know if you've ever seen that graph of the major extinction events, but it tracks the number of species, and then you see it collapse, but then it radiates and explodes again every collapse. So the secular model already has something built in it where this isn't really that much of a problem, but there's real world kind of natural experimental evidence for this as well. I don't know if you've ever heard of those lizards. They're called wall lizards, that they were placed onto these different islands in Croatia. One was called Pod Maracu or something like that. And what happened is they found that the physiology of these lizards dramatically changed in, I think it was a few decades, which for them is many, many generations. But because they're put on different islands and they exploited different niches, the kind of diet that they had on their original island didn't exist on this new one. And so we found these insects, these lizards rather, their heads grew because some of them became more herbivorous. And so chewing plants is a lot more work. And so their heads got bigger to support more muscles in the head. They developed cecal valves in their large intestine, which are the beginnings of fermenting chambers for extracting nutrients out of them, which herbivorous animals have to do that. So this principle that can cut down and in a way sort of simplify the genome is something that you could expect to happen, but it's not like that means that this is what's inexorably always been happening forever. No, it's just that if there isn't pressure for those different changes to accumulate and multiply, then it won't happen. But when there is, then it does, and we've seen it happen.
I don't think you can generalize. Oh, by the way, thank you for that long explanation, and I do appreciate the effort you put into thinking that out. Obviously, we disagree on that, but you talked about stable environments. Nothing was more stable than Lenski's environment, and those things were just deteriorating. So,
well, you say deteriorating, but you're
he used the word decay. So you can identify the names. He had a long list of genes that either got disabled, disrupted, whatever, and they're not recoverable. One of them I am more familiar with is the DCUS gene. And even after 80,000, it only had like a defect of like 5 nucleotides out of like 300 or 400, and it couldn't repair that. And there are more experiments that show that. So even in stable environments, there can be decay. There's also a statement by Dan Grauer, who's an evolutionary biologist that I don't think highly of, but I'll quote him anyway. He said, if ENCODE is right, then evolution is wrong. He's highlighting the fact that if you have a sufficiently complex genome that has a high degree of functionality, it's going to spontaneously decay because it cannot handle the mutations, the number of mutations per individual per generation. This was established by Hermann Muller, who was a Nobel Prize winner who did research on the effect of radiation on heritable diseases. So this is well established. And right now, I think personally, I think it's looking really bad for Dan Grauer and his claim that all these ENCODE researchers at the NIH are crooks and ignoramuses. That was his words, not mine, that he described fellow scientists, and it didn't make him popular. But he recognizes that the point being is that even under very stable environments, if you have a sufficiently complex genome, it's going to spontaneously deteriorate. And that was one thing that Dr. Sanford and I were working on. But it's worse than that, because even the so-called beneficials, quote unquote beneficials in evolutionary biology, things that add to fitness can cause genome decay. And that was Lenski's experiment. when I shared that with Dr. Sanford, I said, hey, John, all the work that you and I did over the last 20 years, he did 20 years, I did 7. I said, that one sentence by Lenski did all the work for us. We both laughed.
Well, I mean, I don't think so, because in the lab, natural selection doesn't really happen in the lab. Not so much. It's what's kind of funny is nature's, in a way, a much better tinkerer and experimenter. Now, the variables are so uncontrolled and confounding that you can never pinpoint one exact thing. But because there's so much going on in nature, it introduces opportunities for all kinds of different changes. And organisms are a symphony of thousands of genes all working together. Those genes, it's called a pleiotropy, right? Where one gene has multiple different functions, but also most traits are polygenic. So in the lab, some introduced condition or whatever, it's very hard to constrain random mutations or whatever to drive it to be beneficial for this one case or whatever. But all the variables are kept very controlled. Whereas in nature, a population can exist across kind of a range of different, not exactly environments, but sort of like microclimates and microenvironments within the broader environment. And so all those different variables all acting at once on the organism, and the polygenic and pleiotropic effects of how gene and gene expression works, means that there's just an unfathomable number of variables manipulating the organism. And so, yes, like, I get it that in experiments we can isolate things, and sometimes you can guarantee survival in a lab, which is another nice thing. But that's also very unnatural as well. Death is kind of a necessary component of natural selection in a way. So I don't personally find the lab things to be death nails or anything like that for that reason, but a lot of other reasons that we haven't really had time to get into.
No, well, I mean, this isn't, again, this is a field that I studied for 7 years. So obviously I would be throwing more data, but maybe to close out before, if it's okay, because it looks like James wants to go to the question and answer or the super chat. I'm going to point out that as far as what happens in the environment, this is a paper by A.P. Hendry in the prestigious scientific journal Nature, The Power of Natural Selection. And he says, adaptation by natural selection is the centerpiece of biology. I don't accept that, but I'll grant it for the sake of argument. He said, evolutionary biologists may be deluding themselves. They may be deluding themselves if they think they have a good handle on the typical strength of selection in nature. So you offered these hypotheses about how selection acts in nature. No one really knows how much is there. So, if it didn't work in the lab, you're hoping it's going to work out there in nature. But I'm just pointing out professionals like A.P. Hendry, very respected. He said, you can postulate these things, but we don't have a good handle on how much there is or is not. And I think there are going to be problems. I will say there's one testable prediction that concerns all of us, and it's kind of sad. This is the one time that I really wish we were wrong, and both John Sanford and I felt this is kind of sad, is that the human genome is deteriorating. There's going to be more heritable diseases. Even if we had a stringent program of eugenics, it's not going to rescue us. And his conclusion is that, like the creationist conclusion, is the only thing that'll rescue us is our Savior God, because humanity is sadly destined for genetic deterioration. We cannot reverse what's going on.
I think this will only take 15 seconds, but I think the biggest contradiction in genetic entropy is it says that the original genome was more pure and less full of these deleterious effects. Well, if you want to do the best possible job of preserving the original genome, then inbreeding would be the way to do that. We know that that's the worst thing you can do for preserving genetic health in a population, is inbreeding. So I think that's the most catastrophic flaw in the logic of the idea of genetic entropy to me.
Into the Q&A, we do have some questions here, folks. We're going to move fast. First, coming in from Yalbadoath, says evolution was intelligently designed by me. Thank you for that. As well as Ifishinatai says abiogenesis. How did life come from rocks / nothing? Let's
don't
say that
believe
you
that-
said that it was only from rocks, because nothing and rocks aren't really synonyms.
Yeah, I don't believe that life came from rocks. This is kind of sort of a composition fallacy. Rocks contain minerals that life, like at one point on our planet there was no life, but there were rocks. There was also water, there was also gases, there were lots of things, and now there is life, but that doesn't mean rocks turned into life. But funny enough, the hardcore creationist does think that's what happened. It's just that the rocks were pulverized into wet clay, and then that turned into life. So it's kind of an own goal.
This one coming in from, do appreciate your question. Plant Base says they found the building blocks of life, DNA, nucleotides, and amino acids on a random asteroid last week. This seems important. Sal, I would think this would be a challenge to you. Go ahead.
You can find random DNA and amino acids in the graveyard. Doesn't mean it's going to assemble. It is important for origin of life researchers that are promoting the idea of naturalistic origins. I think the compelling question is, how did it get up there? There is speculation that the meteorites were sourced from Earth, and that's an interesting speculation, by the way. There are a variety of substances that are in meteorites that are nowhere else except found on Earth. One of them I heard recently was serpentinite, and others. So, I mean, if there was an explosion that sent out the meteorites, it's going to have biotic material, and that is one model of young Earth creationism, where the origin of some meteorites will have Earthborn stuff. So it is important, but perhaps not for the origin of life researchers, because as there's this Humpty Dumpty paradox that Jonathan Wells pointed out. If you take a fully functioning cell and pierce it and let its guts spill out, you have all the RNAs and DNAs and proteins and amino acids and carbohydrates that you would have far more than any origin of life research experiment, and yet the thing isn't going to live. So it's not as promising as some people are making it out to be if you're an origin of life researcher. But if you're a young Earth creationist advocating stuff like hydroplate theory, then you're excited.
Jerry Love Rice, we're going to get your question in just a moment. We have to get Isa Kabir's question out of the way. Isa, yes, I have to read it though. He says, for both, why can't it be both intelligent design and evolution?
It can, it's just that there's no evidence of ID.
It can be, at least, even though I don't believe it. Michael Behe's a good example of that. He believes at least in common descent, which some people will call evolution, but also intelligent design. So there are some proponents of intelligent design that find compatibility between common descent and intelligent design, but they would reject Darwinian mechanisms or random mutation as a source and need some sort of input from an intelligence to make things evolve.
Sea Science Film Lab says, do you understand now that bacterial resistance to antibiotics and yeast, quote unquote, does not reinforce the belief that humans and chimpanzees share a hypothetical common ancestor?
Nobody ever claimed that proves that, although it is supporting evidence of it, because antibiotic resistance is natural selection in action in the real world, basically right before our eyes. But are humans and chimps related? Do they share genes? Yes, that's what it means to be related. So there we go. Get wrecked.
This one from Jerry Love Rice says, question for Peter. What do you think of theistic evolutionists? I am a Christian who fully believes in evolution. Parentheses, Genesis is almost entirely poetic. Peter, I don't know where is that a nickname?
Well, it's the first half of my last name. So, the 3/5 of my or not 3/5. What am I talking? 5/8 of my last name. I don't have an issue with that. I don't debate these people because if you accept evolution and you personally want to be religious, then that's fine with me. It was pretty fatal to me because if evolution is true, then Adam and Eve didn't exist. And if they didn't exist, then there was no fall and there was no reason for Jesus to have ever existed in the first place. The only thing you have to do is imagine, well, there were a bunch of people and then God just magically declared Adam and two of them to be Adam and Eve. And then things happened and now here we are, which is just like, okay, you're force fitting your beliefs into the data.
Oh, James, do we have a lot of people in the question and answer? Because I did want to weigh in on that, but if you're pressed for time, I'm not gonna.
If it's super pithy, I can give you a chance, Sal.
If we find evidence that life is young, then scientifically evolution's refuted. So, and I think that evidence is moving forward because Army Corps of Engineers is doing research on alternative mechanisms of nuclear transmutation that might solve some of the problems of young Earth creationism. So stay tuned. I want to do research in heavy electron quasiparticles as substitutes for muon catalyzed fusion. It's going to be exciting. So don't leave for theistic evolution and think it's a done deal. There's data coming.
Eric can give you the last word since that last one was directed at you.
Oh no, I
Want
said
the last
everything I wanted. I said everything I wanted to say. Let's get to the next one.
This one coming in from Jerry Love Rice. We got that one. This next one coming in from, and then we're gonna wrap up pretty quick here as we I think this is the last question. I'll double check, but Mark Kamaski says, why has Dr. James Tour's challenge on the origin of life not been addressed significantly by evolution proponents, and what is your answer?
I don't know what his challenge is. So sorry, I don't have anything to say with regard to that.
Let's see. For the sake of humoring our question asker, I don't know if you know Sal either, because I know that it's hard to read everybody.
Oh yes, he had a list of about 5 things he was asking other origin of life researchers, and they're more like rhetorical questions and saying, I know you're not going to be able to answer this. I'm showing you guys that you can't be saying we're close to solving this problem because you can't even solve these 5 questions or so. And so this is obviously a challenge to those who believe in naturalistic origins of life. And so my answer would be, it's because God did it.
Wow. We do want to say thank you so much to our guests. Seriously, they're the lifeblood of the channel. We appreciate them, folks. You can click on their links in the description box. And I highly encourage you, even if you disagree, there's a lot of value rather than hearing what, let's say, someone from your side says that the other side says. There's a lot of value from hearing it straight from the horse's mouth, because then you really know that you actually got what they're saying, right? You interpret it yourself. It wasn't straw man by anybody within your own tribe. It's a great way to really understand the other side. So I do encourage you, even if you disagree with them, it's a great opportunity to check out their channels linked below. And I'm going to just do one last check in case you have any last questions. But yeah, thank you very much, Eric and Sal, for being with us tonight. It has been an amazing time tonight. So thanks for being with us.
You're welcome.
Thank you. You're welcome.
With that, folks, thanks so much for being with us. Stick around. I'll be back in a moment with a post-credit scene letting you know about upcoming debates. So stick around, and I'll be right back. Amazing. Oh, that's right. Let me open the old Zoom back up. Want to say thanks so much for being with us, folks. We really do appreciate your support of Modern Day Debate. There are many ways that you do support Modern Day Debate. You might not even know it. For example, we do appreciate when you hit like. It really does make a difference. So you might be thinking like, what difference could it make? It's really not that big, James. I actually think it is. Thanks for your patience. Basically, what I was saying is that we appreciate your support in all the different ways that you give it. And there are a lot of ways that you do give support because you might be thinking, like, hey, well, what do you mean? As an example, hitting like really does help the channel a lot because you might be thinking, like, oh, I don't know if it makes a difference. Believe me, nobody looks at the YouTube analytics more than me. There's a pattern. I really do believe it makes a difference. So we do appreciate, thank you for hitting like. And also, you might be like, hey, what other ways? Well, if you have not yet subscribed, we do appreciate you subscribing. The reason is, frankly, it really does help Modern Day Debate more than the average channel. Because the average channel, they don't really rely on guests as much as Modern Day Debate. So for them, it's kind of like they just make good content or they don't, whether or not they have guests on. No, it's true, some of them will have guests, but usually it's at most one, maybe. Sometimes it's more than one. But Modern Day Debate, it's always guaranteed that we have two or more, right? Because there's debaters. So we really do rely on guests. And the first thing that guests look at when they're considering going on Modern Day Debate is probably how many subscribers we have. So it really does help. The more subscribers, the bigger the guests. Want to say hello and thank you for being a channel member. Kent Speak Hats in parentheses. And it's probing time 666, Nathan Oakley's daddy. Thank you guys for being channel members. As well as Wilmar. I saw you here earlier. If you're still here, thank you guys for being channel members. We do appreciate that extra support. And not only that, but thank you for being a subscriber. I know that if I'm seeing you right now, odds are very good you are a subscriber because we almost always turn on subscribers chat mode. So I want to say thanks for being with us. ZH Kane, I see you there in the old live chat. Kevin Howe, thanks for being with us, as well as the 11 and Nemrod X, as well as Aaron Pimentel and Sydney Raptor and No Name Body. Sandy Pigeon, good to see you, longtime viewer of Modern Day Debate. Thank you guys for all your support. We appreciate it more than you know. Now, this Wednesday, we might have a debate on God's existence. There's Wilmar. I see you in the live chat. Says, I was lurking, skulking around in the old live chat. Thanks for being with us, Wilmar. Thanks for hanging with us. Dylan Moats, good to see you. So the way this works is, yeah, we're excited, though. Just all sorts of cool stuff coming up. This Wednesday, we might have a debate on God's existence. And then let me look at this right now as well, because I know that I think we've got one scheduled for Friday. Let me check this out. Hey, check this out. Is on Friday. No. So Thursday, we may have a debate with Rachel. That would be on whether or not feminism is helping women. And then Saturday, debate with Justin, deconstruction. First time coming on the channel, and Wi-Fi Gospel, also his first time coming on the channel. So that should be a lot of fun. That's on Saturday, so that's 1 week from today. So I think we have two. Was it one? Let's see. Let's see. 1, 2. So we have potentially 3 debates next week. And then, yeah. So we're excited though about the future. Thanks for all your guys' support. I'm gonna eat. I'm so hungry. I'm going to let you go, but I want to say thanks for your support. I love you guys. You make this fun. We're excited about the future here at Modern Day Debate, including DebateCon. Is it DebateCon 6? Yeah, it is. It's crazy. DebateCon 6 this fall will be in Nashville, Tennessee, if you haven't heard. We're excited about that. So we're looking for a venue, and it's going to be amazing. Thank you guys. Love ya. Keep sifting out the reasonable from the unreasonable, and we will see you at the next debate.